Welcome to part 2 of integrals by trigonometric substitution. In this video we're going to solve one long and hairy problem involving trigonometric substitution. This is the problem. We want to find this integral. The integral of x squared over the square root of x squared minus 16. And well, the only thing we can try here, well, you can maybe even try integration by parts, but the easiest way to solve this is to use trigonometric substitution. And if you remember from part 1, in this case we will want to use identity, this trigonometric identity, because here we have a difference between x squared and a constant. So we want to use this identity, and the way to do that is, well, we can try to write this integral like this. We can factor the 4 here, the number 4 here, and because the x squared doesn't have a 4, isn't multiplied by 4, we had to divide it and square that. Minus 1, because this is 4 squared, right? So we can write the integral like this. And now this expression here looks very similar to the one we would have if we subtracted 1 from both sides of this equation. So we use the substitution x over 4 equals secant of t. That means that x is 4 times secant of t. And you also need to find the x, so we take the derivative of x with respect to t, and we get, well, we know that the derivative of secant of t is tangent of t times secant of t. So multiplying both sides by the t, we get that dx is this expression here. So we have x, we have dx. So we can make the substitution. This is our integral, and we can make that substitution. Here we have that this factor here is x squared, because 4 squared is 16 times secant squared. This factor here is dx. And in the denominator we have that this is x squared, and that minus 16. And now we can multiply 4 times 16 is 64. Then we have the tangent of t, and we will have secant cubed of t. And in the denominator we can factor the 16 like this to get this expression. And now we can take the 16 out of the square root sign. Well, we just did that. And now we can notice, well, what we have in the denominator. We will use this identity again. Here we have secant square root t minus 1. That equals tangent square root t. But here we also have the square root, so we will get that this square root is tangent of t. So we replace that in our integral, and we can cancel the tangent of t with the 1 denominator. And 64 divided by 4 is 16. So we finally get this trigonometric integral. So our problem reduces to solve this trigonometric integral. There is the integral of secant cubed of t. I don't know if you have already solved this integral, but this is not an easy integral. It is normally solved using integration by parts. And well, this is not a video on integration by parts, so I'll only give you the answer. And the answer is this one. It is very long and complicated because I think you need to use integration by parts twice or something like that. So this is the answer. And what we are going to do here is to substitute back. So remember that our substitution was using x equals 4 secant of t. That means that secant of t is x over 4. But here in our expression here, we also have tangent of t. So we also need to get tangent of t as a function of x. So we use again our trigonometric identity. Tangent of t is secant square root t minus 1 and the square root of that. So we had secant of t is x over 4. So secant squared is x squared over 16 minus 1. And we can take 1 over 16 out of the square root sign, and we can write this expression like this. Now we're ready to substitute back. We have this is the answer to the integral, and we have the expression of secant of t and tangent of t as functions of x. So we substitute back and we get x times secant of t, that is x over 4, times tangent of t, that is this expression here, now plus 8 times the natural log of secant of t, that is x over 4, plus tangent of t, that is this expression. Now in this first term here we can simplify some things. Here we had the 8 divided by 4, that is 2, and now 2 divided by 4 is 1/2. So the expression that remains is this one. So finally, our final answer will be this one. Okay, this was a very long problem. I hope you liked it, and that's all for now. Thank you for watching and see you next time.